She's here, perfect. So our next speaker is Magdalena Baranowska, who is going to move us to Mars and to the northern plains of Mars and discuss some features that may have maybe some astrobiological potential. So Magda, if you can share your screen.
Okay, I'm trying to find where is it? Okay.
Perfect. Not yet, full screen. Awesome, perfect. And I will let you know when 10 or 12 minutes passed, depending on, I don't want to break your flow. So 10 or 12 minutes, and then when you will be getting closer to the end of the presentation. Go on.
Okay. Hello, everyone. My name is Magda. I recently graduated geology at Adam Mickiewicz University in Poznań. And today I would like to present new features found on Mars in Utopia Planitia that were mapped during my master's. So Utopia Planitia is one of the major depressions on the northern part of Mars formed by a major impact. It is surrounded by volcanic regions like Elysium Mons on the east or Arabia Terra on the west. And important part of Utopia geological history was existing water in the past. On map seen in green are fluvial sediments filling the basin of Utopia. Also in red, you can see the volcanic sediments. Right now, Utopia is covered with ice-rich mantle called latitude-dependent mantle. The environment is cold and dry. Many features observed there show similarities to periglacial structures, which are found on Earth, for example, in Siberia or North Canada. Structures like scallops, pits, gullies, or polygons on Earth are formed as a result of freezing, thawing, or sublimation cycles, and many of these structures are observed in a lot of places in Utopia. Other structures like glacier-like features, mantle texture, and deposits are also believed to be formed involving the ice presence. There are still structures with unknown origin, like this one, that we found during our mapping called low elevation mounts. They haven't been mapped before. Some of these mounts show characteristic fracture at the top or subcircular features covering the summits and surroundings. Also, the dark material is accumulated on the summit of this mount. So we decided to take a look at those mounts and found the study area in northwestern part of Utopia. And the area is surrounded by several impact craters seen here, and tectonic ridges that you can observe here and at north and south part of the area, with northeast and southwest orientation. Also, this area is away from any volcanic regions that we know. For the research, we established that the low elevation mounts are not distributed randomly, like impact craters. And as many structures on Utopia are connected with volcanic or hydrovolcanic activity, we can assume that low elevation mounts have endogenic origin. The mapping process started using a JMARS program when we analyzed the CTX images mapped all structures, and then all this data was moved to QGIS program or ArcGIS program. Also in JMARS, we collected MOLA shots. You can see them as MOLA tracks on the right side. They were used to calculate the height of low elevation mounts using the Excel spreadsheet. These tracks are filled with individual laser shots from the satellite to the ground. And as a result, we mapped 131 low elevation mounts with height in the range from 5 to 65 meters. Most of them have less than 30 meters height, and the longest axis diameter is from 1 to 7 kilometers. The longest axis diameter is oriented mostly approximately east-west. And the small height of this feature and long axis means that the slope is very low, is approximately under 1 degree. Some of those structures shows the fracture at the top, 33, one of them, and the fracture width is from 100 to 300 meters. We can divide those mounts morphologically into mounts with smooth surface without any characteristics structures on top, and cratered with subcircular features, and fractured with the characteristic fracture at the top, and also with subcircular features surrounding the area. A lot of these mounts show also the dark accumulation on the top. The analysis shows that the low elevation mounts are clusterally distributed, with the great cluster at the south part of the area. And also some of them show the linear alignment that corresponds to tectonic ridges outside the study area. So what are these features? What is their origin? Geologically, they show similarity to mud volcanoes and pingons, which are also present on Mars. Mud volcanoes form as a result of movement of large amount of sediments and mixture of fluids. The height is from 20 to around 300 meters, and the longest axis can vary from 50 meters to even 8 kilometers. The slope is mostly less than 50 degrees. Some of them show around 5 degrees of slope. Comparing to low elevation mounts, the height in the meter, we can see it's similar as long as slope, but morphologically, mud volcanoes shows the caldera-like on the top of the structures, or some kind of crater, and also the mud flow-like feature coming out of the caldera, which is not present in low elevation mounts. Also, the sediment differentiations in mud volcanoes, mostly the mud volcanoes are built from different sediments than the surrounding area. This is also not present in low elevation mounts, but different type of structure like pingo with periglacial origin, which are formed as a result of pressurized groundwater migration and accelerating freezing under hydrostatic conditions. Pingo also have very similar height to low elevation mounts. The longest axis diameter in low elevation mounts is a bit longer than in Pingos, but the slope is much steeper in Pingos comparing to low elevation mounts. The other thing that it's worth mentioning that Pingos are very common in Utopia Planitia, and they have very broad range of different types of morphologies, and also the summits are sometimes covered with fractures that that they show through sublimation of ice on Earth and probably also on Mars. So we decided that the low elevation mounts probably have similar, like Pingo-like origin. To sum up everything what was stated, the new features called low elevation mounts are small mounts with a long axis diameter, which means that there is a very low slope. They show characteristic fracture at the top or circular features. Some don't show any type of characteristics. And the analysis of the fractures suggests permafrost origin. We can say pingo-like structures, which formation involves ice movement on, we can say, maybe even liquid water. And this discovery could help understand the current Mars, and especially help in searching the possible liquid water, the important component of our future Mars explorations. And thank you.
Perfect. You are very quick, which leaves us a lot of time for questions. Perfect. So first question from Jan Spacek, who should also add himself to the people that will be presenting, because he's next and he's not in the lineup. So please, Jan Spacek, do that. And he asks, can we date pingos on Mars? How old are they?
We can probably date them with the stratigraphy of rocks, and we can see on what kind of sediments they are observed. For example, in Utopia, it's a very recent, not very recent, but the most recent mantle, and it's from the Amazonian age, so a few millions years. But we can't literally interpret the date of pingos on Mars.
Mm-hmm. Would you like to comment on the possibility of using the crater counting method on them?
It's a good method, but a lot of these craters can also not be the impact craters origin, so there is a possibility that we have a lot of mistakes using that method.
Yeah,
it's the best so far we have. So.
Mm-hmm. Do we have any other questions about the origin of those strange features on the surface of Mars? If not, I will have some. So how do you think this study is going to influence our understanding of the potential for astrobiological findings on the surface of a planet? Can they have any astrobiological meaning?
Well, this area is known from the ice enrichment on the ground. So ice means also water, and water means life. So it's very interesting.
Well,
place.
Can mean life. That does can not meet.
Okay.
Yeah.
Okay, can meet.
Perfect.
And it's a interesting place to first find something like that if we know that there's ice, and search for something more there than just I don't.
Okay. We have a new question. Yet I think that yes, there might be. If we have pingos, it means that there might have been some waters, if those features are indeed pingos, or at least some water migration, which is still promising. Okay, we have another question from Priya Sarma. Water or brine? Any thoughts in those pingos?
Oh, well, we don't have any evidence of liquid, like for a long time, liquid water on Mars, but we know there is a brine. It's a
I
solution of
think
salt.
Magda, I think the question is, do you think that the pingos are related to clean water or brines?
It's a great question, and I'm not sure, and we would need more chemical evidence of that, not just the structures. But I can't answer the questions like yes or no.
Perfect. So another reason to land a rover with a drill coring device on Utopia Planitia. I will drink water to that. Yes, perfect. If you have any other question, you can type it very quickly up right now. If not, we can session. For that, you need to get out of this one and go to the next session.